Hello friends, today I am going to talk about question number 1 of GATE Physics 2017, and this is a electrostatics based question. So the question looks like this. Identical charges Q are placed at 5 vertices of a regular hexagon of side A, and we are asked to find out the magnitude of the electric field and the electrostatic potential at the center of the hexagon. So we are given 4 options, so we have to choose one of the 4 options. So the solution to this question is like this. Now we have this regular hexagon and we have 5 charges which are located at the vertices of this regular hexagon, and each of the sides of this regular hexagon measures A. Now we know that for a regular hexagon all these angles are 60 degrees, and therefore the distance of the charges, each of the charges from the center, will also be equal to A. So this distance will be A, this will be A, this will be A, this will be A, and this will be A. Now we know that the potential V is given as 1 by 4 pi epsilon naught times the charge divided by the distance, and if we have multiple charges, then the potential is just the superposition. So we have to add up all the contributions. So the total electrostatic potential at the center O, which is V naught, will be given by 1 by 4 pi epsilon naught times the charge divided by the respective distance, which is A in all the 5 cases. So it will be Q by A, Q by A, Q by A, Q by A, Q by A. So it will be 5 times of Q by A, and therefore the total electrostatic potential comes out to be 1 by 4 pi epsilon naught times 5Q divided by A. So this is how our electrostatic potential looks like at the center O. Now let us see what about E. Now if we draw the electric field directions, so we can see that at the center, due to this Q1, the electric field will be along this direction. For this Q2, the electric field will be along this direction. For Q3, the electric field will be along this direction. Similarly, for Q4, E4 will be along this direction, and for your Q5, the electric field will be along this direction. Now, since all these 5 charges Q1, Q2, Q3, Q4 and Q5, they are all equal to these Qs, and therefore this E1, E2, E3, E4, E5 all will have the same magnitude, and because of that E1 will exactly cancel out E4, E2 will exactly cancel out E5, but we don't have any other component opposite to E3, and therefore the net electric field at the point O at the center will just be only equal to E3, and therefore the total electric field E at the center will be equal to E3, which we know is given by 1 by 4 pi epsilon naught times the charge divided by the distance, which is A, and we know we have to square that. So the total electric field E will be 1 by 4 pi epsilon naught times Q divided by A square. So if we see from the options, the correct option is my option C. So this is the electric field and this is the electrostatic potential. So that's all. Thank you.